Let's get started. No. Okay, so can I have your attention? Because our topic is condensing logarithmic expressions. Okay. All right, so here's what we know. Log of m plus log of n is equal to what? Log of m times n. And which property is that? Product. Whoever has the restroom, just go. So log of m minus log of n, what's that going to give us? Log of m divided by n. And which one of our rules was this one? That's our quotient. And we had one more of our three basic rules, and that was if p is positive, p times log of m is equal log of m to the p power. And that was our power rule there. So when we expanded logs yesterday, we started from the right-hand side and we went to the left. So now you're going to get logarithmic expressions that are already expanded, and now we're trying to rein them in and make them into one single log. So we're condensing. So example, let's say we have log base 4 of 2 plus log base 4 of 32. Now this particular problem on its own, the way it's written, we probably have to modify it a little bit to see if we could find a numerical value here. But if we condense this, if we look at this, we see that, hey, I could use the product property of logs. Same base, so this would be log base 4 of 2 times 32, which is the log base 4 of 64. Now, can we come up with a numerical answer here? So what is it? What's the log base 4 of 64? 3. Because 4 to the third power is equal 64. And you guys know your first 10 cubes anyway, right? So you reckon you saw 64 and you're like, oh yeah, that's one of my cubes. All right, another example. Log of 4x minus 3 minus the log of x. So the log of 4x minus 3 minus the log of x. Any particular property we're going to use here to condense it? Division or quotient? So if we use our quotient rule here, then this will give us the log of, so it's numerator, denominator, 4x minus 3 divided by x. Now, it would be so nice if tomorrow's quiz I were to give you problems like this, but you know that that's not going to be the case. This is just to get us warmed up. Now, this next statement is really important when you're talking about condensing. So the coefficient of your logarithms they must be 1 before condensing. Using product and quotient rule. So we have to make sure that the coefficient of your log, so whatever number is in front of your log, that needs to be 1. So before we start condensing, all of our logs have to have a coefficient of 1. So really what that means is that if you have a value or a constant in front of that log, you're going to need to use the power rule first. You need to move that number from in front of the log before we use product and quotient rules. So we have to condense that way. So with that said, let's say we have 2 times natural log of x plus the natural log of x plus 1. So right now, we can't condense until that 2 is, well, we're not going to get rid of it. We can't just erase it. So it's not necessarily gone, but we need to rewrite this log. So we're going to rewrite it using our power rule. So 2 times natural log of x is the same thing as natural log of x squared plus natural log of x plus 1. Now that the coefficients of our logs are 1, now we can use our product rule to condense this. So here, this will be natural log of x squared times x plus 1. Okay, so again, before you condense, the coefficient of your log needs to be 1. Any questions on that? Yes. You can. So an equivalent expression would be natural log of x cubed plus x squared. Yes. You do not. If this were a free response problem on a quiz or a test, I would accept either of these values. If it were multiple choice, you would determine just by the way the distractors are written which one it would be. Distractors. You know the distractors. They give you one right answer and 3 or 4 wrong answers to distract you. Yeah. Tricky test makers. All right, next example. 1/2 log of x plus 4 log of x minus 1. So 1/2 log of x plus 4 log of x minus 1. All right, so you guys try this one. All right, we ready? Okay, so how about Christian? What'd you get?
Log of x to the 1/2.
Okay. Oh, okay. So your final answer would be log of x to the 1/2 times x minus 1 to the 4th. All right. Or the square root of x. So it seems like what Christian did, and correct me if I'm wrong, is he did everything in his head at once, or did you just give me the final answer? Or did you do a step by step? Okay. So log of x to the 1/2 plus log of x minus 1 to the fourth. Then from here, we're able to go there. And if you were to see this probably on a quiz or a test, multiple choice, you would probably more than likely see it written as log of square root of x and then times x minus 1 to the fourth. All right, enough of these baby problems. Let's take a look at this next one. All right, how about 4 times log base c of x minus 2 log base c of 6 minus 1/2 log base c of y. So the only thing I'm going to say beforehand is be careful on this one. So 4 times log base c of x minus 2 log base c of 6 minus 1/2 log base c of y. Okay. It seems as though all 3 of these logs, they have a coefficient in front of the log. So remember, that coefficient has to be 1. So we are going to have to use our power rule. So log base c of x to the fourth minus log base c of 6 squared, and that'll give us a constant, that's 36, minus 1/2 log base c, minus log base c of y to the 1/2. Okay. Now, this looks like we're going to have a quotient rule, right? My only concern is, look at that right there. So we're like minus, and then we're minusing again. What is going on there?
Can we solve for log base c of 6? Because when you do the quotient rule, you have the minus sign, but you distribute it to both. So there's a product rule on the bottom.
Okay, so there will be a product on the bottom. So do I want to do the process of, so I think I understand what you're saying. So log base 4, then you're saying, so this is minus, because you said a product rule. The only way I'm going to get a product is if I have a plus.
Like minus log c of 6 squared and then plus log.
So then I would have a parentheses.
Yeah.
And then this would be log base c, and then the 6 squared is 6 squared is 36. And then a plus log base c of y to the 1/2. Okay, just as long as we don't change the original. So if we were to distribute this negative, we would get negative log base c of 36 minus log base c of y to the 1/2. So that works. So now this becomes, so here's my numerator, there's my denominator. So this would be log base c of x to the fourth divided by 36 times y to the 1/2, or 36 times the square root of y. So that would be our solution. Okay, let's go ahead and end with the change of base property. So our change of base property. Let's say we want to evaluate the log base 3.5 of 36. Okay, so what we know is that to write this as an exponential, this would be 3.5 to the x is equal to 36. So how do we evaluate this numerical value? If we take a look at our scientific calculators, what we notice is that we have a common log feature and we have a natural log feature. But we don't have a feature that will allow us to evaluate the log of any other base. So here's where the change of base property comes in. So for any logarithmic basis, a and b, and a positive number m, we can say the log base b of m is equal to the log base a of m divided by the log base a of b. So what's really important here is that these bases are the same, but we have changed the base from b to a. Okay. So why is that important? Well, it's important because our calculators allow us to evaluate common logs. So if I change my a to a 10, then that's equal to log of m divided by log of b. Or if I change my base to e, that's the natural log of m divided by the natural log of b. Okay. So the change of base formula allows me to evaluate something like this by using common logs, changing the base to a common log, or changing the base to a natural log. Okay. So let's take a look at evaluating log base 3.5 of 36. So that's going to be the log of 36 divided by the log of 3.5. And in this property, just make sure that your base is always your denominator here. So if we were to take a look here, so we want the log of 36, so log of 36 divided by the log of 3.5. Log of 3.5, and we end up with 2.86049,239. Now I told you have an option. If we were to evaluate this using natural log, it's the same thing as the natural log of 36 divided by the natural log of 3.5. And look at that. We get still the same value. So as a matter of fact, it really doesn't matter what base you change it to. As long as they're the same, the numerator and the denominator, we can use our change of base property. So this value is approximately equal to 2.86049,239. Okay, now I did want to show you one thing. For those of you who are going to be going on to Calc next year with me, the calculator that we use actually does have that function in there. So it does actually allow you to find the log with a different base. So our initial problem was the log base 3.5 of 36. So here, if I go log, notice here that it allows me to choose my own base. So log of 3.5 of 36, and there's my solution, 2.86049, which is what we got before. Okay, now let's say instead I change my base to something else. So here I just want to show you. So let's say we're still finding the log base 3.5 of 36, but let's say this time I'm going to change my base to 2.67 of 36 divided by the log, the base of 2.67 of 3.5. So notice what we get. So that change of base formula, again, it allows you to change your base to anything. But because we have scientific calculators, we're going to be changing our base to either a 10 common log or e natural log to evaluate these. Okay. So that's it for today's lesson. Homework problem is on your sheet. and we'll see you tomorrow.